Welcome back to my channel EduVibe. So today we will learn about the second topic of the matter and the chemical bonding, which is the ionic bonding theory. So this is a theory work which we will do today, not like a very examples we are doing. We just know about the theory which we use in later on lessons. So this is the grade 11 chemistry. We will learn about the ionic bonding theory. So what is ionic bonding theory and what the things which we have to know about this. So firstly, we have to know about the orbitals. So in ionic bonding theory, in my previous videos, we will discuss about the orbits like this. So here we have orbits like the first orbit, two orbit, the other energy levels, which we discussed in our previous video. So orbitals are the things which these are the orbitals which we made. So these are the orbitals. So orbital is a specific volume of space in which an electron of certain energy is likely to be found. So in the orbitals, on the orbitals, like we made the orbital, and on this orbital we have the electrons, where we found the electrons which are flow on this, which are negatively charged electrons. So there is a volume of space of this orbitals where the electrons to be found. Orbital may be unoccupied, certain one electron, or contain the two electrons. So there's a thing that sometimes the orbital has on no occupied. This means they have a zero number of electrons. Sometimes they have one electron. Sometimes they have the two electrons. So it depends. So here's the table, small table, or the orbital number of electrons, description, and the type of electrons. So first one is the empty. Empty means unoccupied. So unoccupied we have a zero electrons, and this is nothing, and this was nothing. Half filled means there's a maximum of two of them. So the half filled means only one of this. So the description is they're unpaired. If we have only like one electron, we have only one electron over there, so it's only does not have any pair in this. So this is the unpaired electron, this one. So this means that there is unpaired, and type of electron is bonding. They bond with the another things, they bond with the orbit, they bond with the another electrons if they have. Filled means the two electrons they have, and they call a lone pair. Like same like this, we have the another electron in over there, and this one. Now these two are the filled one, this orbital is filled, and now this two electrons made a lone pair. When we have a two electrons to the other, so this means this is the lone pair. When the two electrons join together being a one pair, they become the lone pair, and we have to call them the non-bonding. They don't do the bonding, they are the lone pairs. So next one is the electronegativity. So electronegativity we will discuss in our lesson, that if we made like any element, we made the Fe element in the last video, and we see that over there's a small number which is I think 1.8. I think it's 1.8 something, and this 1.8 denotes the electronegativity of the particular element. So, what is electronegativity? Electronegativity is the relative ability of an atom to attach bonding electrons. So, the relative ability of an atom to attach bonding. So, the bonding electrons can be attracted by this relative ability of atom, which is the electronegativity. So, electronegativity is on the elements. Each element have their specific electronegativity. So how it be like, how can we know about this? So it increases with the decreased number of energy levels. In the aluminium, I said we have a three bonding electrons, we have a three energy levels, and for the hydrogen we have only one of them. So they increases, the electronegativity increases with the decreased number of energy level. We have a three energy level, they have one energy level. So this means helium, that hydrogen has the more electronegativity than the aluminium one. So that's how it works. So next thing, that the element in the period horizontal row have the same number of energy levels. On the horizontal row of the one period, like same number of energy. Like we have a periods over there, like we know, these are the periods, 1, 2, 3, 4, 5, 6, 7. So each horizontal row, there these horizontal row, these and these all have the same energy levels. So this means they all have the same electronegativity by the degree, by the same literable electronegativity, but not the very same, because every element has the different ability to interact with each other or not. The further away of the nucleus, that electrons are weaker, their attraction of nucleus. So if we go over the further away from the nucleus, the electrons are weaker than the attraction. So if any element has their about, like, this is the element and this has the number of energy levels, this is a maximum of 5. So how far they go to the nucleus, so the weakest attraction to the nucleus they have. So that's how the electronegativity depends on the elements, the vary they are the energy levels, or they have the how far they from the nucleus. So next thing, that the electronegativity increases the atomic number within a period. Specific period, if the atomic number is increases, so the electronegativity also increases with this. Greater number of protons they have, this means atomic number in the nucleus, the greatest attraction for the electrons they have. So how the greatest number of protons with the nucleus, they're the greatest attraction for the electrons. So this will remind me that you have to know that the atomic number is equal to the number of protons. Next thing, that metals tend to have a low electronegativities and the non-metals tend to have a high electronegativities. So here we do, like, if we see over there, like these are the metals and these are the non-metals. So you can see the non-metals hidden right, I think. So you just know about that metals have the tend to have a high low electronegativity, the metals are the high one. So you can see from your data booklet too, here you can see that the electronegativities of the metals are very low in as compared to non-metals. So one more thing to cover is that the ionic bonding. In the next video, we will learn about the ionic bonding with the electron dot diagrams, which we already discussed in the last lesson, but will more in the picture form, which how can we make the lat ones. So in this, we have to know that the octet rule, which is a dude rule in the case of hydrogen, states that chemical reactions involving sharing or transfer of valence electrons, so that each atom has the complete valence shell or the stable octet. So we'll follow the octet rule in our next lessons now. So that octet rule will state that the all the we will either sharing or we transfer the valence electrons to complete the valence shell. Valence shell is the outermost shell. If the aluminium has the three energy shells, so if they in outer mode they have only two of the three of the electrons, so there should be the eight, or we have to like take the three out to stable that auto rule. So we have to stable the auto rule by sharing or transfer. We will do sharing too, we will transferring to in the later on lessons, and we will know about how can we stable auto with these two methods. Last thing, that the ionic bond is the simultaneous attraction of the positively charged ions, and it is very strong bond. So in the last we will just conclude that the ionic bond is the simultaneously the attraction of the oppositely charged ions. The oppositely charged ions, if you have a positive, if you have negative, they all attract with a very high attraction. And there's a very strong bond. When we make that bond, there's very strong bond. Nobody can break that bond. If we see the example of the ionic bond, there is the electron transfer. If you do the electron transfer, how they do, like we have an Na over there, we have a Cl over there. That Na has only one on the outermost shell, so they transfer to the Cl because the Cl has an outermost shell, they have only 7, so they have to stable this. So they transfer that one electron to this becomes stable, and this also becomes stable. This will gain that give the electron to Cl, so to become positive, and this will get that gain that to those electrons, so it's a negative. This will be N plus and Cl minus, which will later on become the NaCl. So that's how we can do the electron transfer, or the sharing will do the in the another method. The electron transfer goes like this. We will discuss more in the next lesson. So yeah, so this is all for this lesson. We will learn about the ionic bonding. We learn about the theory work today. In the next we will do the practical work too. How can we make that those valence shells? How can we transfer that? How can we share that? So that's we all covered in this lesson today. So learning made simple with EduVibe. Learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions related to this topic, let me in the comment section. See you in the next video. Till then, stay connected with Edu.